How to use the CSP for understanding the scleral profilometry? We have a lot of numbers, but we also need to understand the colors and the numbers on the map. So in this case, we have a ring diameter set to 16.4 millimeter, and we will go step by step. Now, understanding the upper part of this display, at 16.4 millimeter, we have a sagittal height of the ocular surface, a flat meridian, which is about 3,931 microns, and in the steepest one, 4,327 microns. The toricity, which the difference between these two meridians in this case is 396 microns, and we have the value of the mean sagittal height, which is 4,129 microns. So these are the information regarding the ocular surface of this specific patient and this specific ring diameter. How to use this information to apply them in the scleral lens fitting? If you need to put the central clearance, initial central clearance, and in this case we put the central clearance 350 microns, what the software will be doing is adding 350 microns to the mean ocular sagittal height, which was 4,129, and it making for us the calculation, which is 4,479. In this case, what you need to do is go to your trial set of lenses of 16.4 and pick the lens of 4,500 microns to apply it on the eye. This is how the software helps you in selecting the correct lens from your trial set. The CSP will also give you an idea of how much toricity you have in this case, if you need to order a toric lens or probably also in a quadrant-specific lens. So in this case, we have 396 microns. We will round it to 400 microns. What does it mean? This is the value of the difference between the two main meridians. However, how this is distributed on the ocular surface? Would it be minus 200 and plus 200, or minus 50 microns, or plus 350 microns, or minus 100 microns and plus 300 microns? So you can see there are a lot of combination to get to a difference of 400 microns. Important thing is to look at the map in the lower part of this display and look at the numbers in this map. What you need to do is to average the numbers, the superior and inferior together. If there is not too much difference in these numbers, otherwise you would have a quadrant specific, but in this case we have very close number between superior and inferior one. You need to average them, and averaging them we get to around minus 230 microns in the vertical meridian, which is the steepest one. Now doing the same in the flattest meridian, I can average the numbers, which are not too much different between the nasal and the temporal one, and my average number is 167 microns of elevation in the horizontal meridian. What does it mean? That the distribution of the toricity for 100 microns is not always minus 200 and plus 200. In this case, we have minus 230 and plus 167. So the distribution is not symmetric, is depending on every case. You need to look at this map. Now, understanding how to read the CSP and all the numbers, you can also select the lens parameters without applying any lens on the eye. So you can start by ordering a first diagnostic set and apply that as first trial set on the eye. What we can deduce from what we just saw, that a scleral lens of 16.4 millimeter need to have a sagittal height of 4,500 microns, and it needs some toricity, and the vertical meridian you may order minus 225 microns, and the horizontal meridian plus 175 microns for this ocular surface. So by looking at these numbers and the color map in the lower part of this display, you are understanding the ocular shape, but you are also selecting your first trial lens to start with in your fitting process. Now what is missing is the power of the lens, because we have all the parameters. What you need to do in this case, apply any rigid contact lens on the eye, not necessarily scleral lens, especially in significant toricity where you may have air bubbles coming inside the lens and disturbing vision, so it will not allow you to perform an over refraction. What you need to do, apply any corneal lens with a small clearance, apical clearance, to perform the over refraction. What you need to communicate to your lab, the base curve of the lens power, and the over refraction, and the lab will calculate the lens power. So in these cases, the empirical fitting, you apply a lens on the eye only for over refraction. Otherwise, you are using all the information from the CSP to determine lens parameter and start from that lens. Now, by understanding the scleral shape, you can also predict how your lenses in your trial set will behave on the eye. So in this case, we saw that we have scleral toricity, and the distribution of the scleral toricity, we already determined it. We have minus 230 microns in the vertical meridian and plus 167 microns in the horizontal meridian. You are applying a lens that is toric, and the toricity 150 microns, which means that you have minus 75 and plus 75 microns. How this lens would behave on the eye? You have your lens that is minus 75, but it's not deep enough to cover your minus 230 microns on that ocular surface. So your lens will be lifting off in the vertical meridian, and you will have huge influx of fluorescein and accumulation of fluorescein behind this edge lift. This is the horizontal meridian. Same thing on the vertical meridian. You have your lens which is elevated plus 75, but the ocular surface is elevated plus 167. What does it mean? That your lens that is less elevated than the ocular sagittal height will be compressing on this meridian, so you will see blanching and indentation. Without applying any lens on the eye, you will know that the lens of your trial set, you will behave like the lens will be lifting in the horizontal meridian and will be compressing on the horizontal meridian. And more likely the lens will decenter because you don't have enough toricity in, at least in the vertical meridian, to have the lens aligning with the vertical meridian. So we saw how to average the numbers between the two opposite quadrants. In some cases, this is not possible because the two opposite quadrants have a lot of difference. Like in this case, in the vertical meridian, they are quite similar. However, in the horizontal meridian, you have a huge difference between the nasal and the temporal. So in this case, it's not possible to average these values. What you need to do is to order a quadrant-specific with different values in the nasal and the temporal area. What is very important also to look at in this case is in cases where you have significant asymmetry in the same meridian between the two opposite quadrants of the same meridian, you will see in the corneal scleral profile that how the nasal area is more elevated compared to the temporal area that is lower in elevation. which is like a mountain that we saw in previous presentations, where an area was higher in elevation and the other one was less elevated. And this is exactly the case in this eye, where you have significant difference in elevation between the two opposite quadrants.